Hi guys, I'm Darren, and in this video we're going to be carrying on with our iNav 5 Beginners Academy. So before carrying on with this video, I'd just like to take a moment to say thank you to all my supporters on Patreon. In particular, I need to give a shout out to Andy Moore, Fred Bowen-Smith and Andrea, who have joined me on the pilot's level or above. So thank you very much guys, but thank you to anyone who supports me on Patreon or through any other methods. It really does help in the creation of this channel, and in fact making this video has been made a lot more possible because of your support. So everyone out there should be thanking them if you're enjoying this series. If you wanted to support me on Patreon, it's completely optional, it's up to you. There's a link in the video description. I've been told that I don't mention this stuff enough, and I've been told off for it, so I thought I'd get it out there. But yeah, if people want to support me, it's their choice. I don't try to push it on to people, but I really do appreciate all the support guys. Thank you very much. But let's get back to the video. So in the last video we took a look at flight controllers, and we also got iNav installed on our computers and got iNav flashed to our flight controller. After that we ran through a basic calibration and took a look at the mixer to see where we need to put our servos. So in this video we're actually going to start soldering stuff up on the flight controller and get the FPV gear into the plane. So instead of yapping on, let's get to the desk and carry on with the build. Alright, so as we discussed in the last video, we need to connect a few components to this flight controller. The basic components that we're going to be connecting is the video, which is in this block here on this flight controller, which is going to be our C1 pad for the video camera in, and our VTX. On some boards there's only one camera, so it says cam. For C1 and C2 are for if there are two cameras, but for this initial part of the build I'm just going to be hooking up one camera. We'll hook up our video transmitter, and we'll hook up the power and ground for those two components too. We're also going to connect our servos, so we'll add a couple of headers for the servos, and we're also going to add connections for our receiver and our GPS. Now on this one I will be using TX2 RX2 4.5 volts and ground for the receiver, and I'll be using TX6 RX6 4.5 volts and ground for the GPS. Now at this stage it's up to you if you want to put the pins on everything or just what you're actually going to use. I'm going to basically put what I'm going to use on here and also plan ahead. So I will be putting pins on the camera too as well, and maybe some other UARTs for connecting other things later on. So this first part of the build is going to be soldering on the pins. I decided to go for pins because it will be easier to swap parts out when sort of doing the setup and showing you guys different ways of doing things. The main power in and the ESC out will be direct soldered, and that's going to include the signal for the ESC and also this RX8 here for the ESC telemetry. If you're using the plug and play kit, the ESC doesn't have telemetry, so don't worry about that. If you're using a different flight controller where you haven't got a UART here, any spare UART will be fine to use for your ESC telemetry. But what I would actually recommend doing is not using UART 1 unless you actually really need to. The reason for that is if the USB cable breaks, then you can connect a device to UART 1 to connect to the flight controller, so it's not all lost. So one other thing to mention before we move on is on this flight controller you will notice that there is an arrow. Now in this early stage of building models, I would recommend to have this arrow pointing forwards. So for example, in our model, we're putting it in a rear bay, the arrow would be pointing forwards towards the nose of the model. So basically the arrow is facing the direction of flight. That will just make setting up simpler in this instance. As I've mentioned in earlier videos, we can actually change the orientation, but at this stage, just make sure that the arrow is pointing forwards. It'll be so much simpler. I will show how to do it in Configurator, but where everyone's new to this, it's just easier to simplify things. So make sure that the arrow is pointing forwards. So I'm going to talk through some of this, but I will just skip some because soldering is soldering. It's something that if you're not good at it, practice really helps. And you can get sort of breadboards and stuff like that cheap enough to practice on rather than practicing on your flight controller. So the first thing I'm going to do here is pull this one apart. Some boards, some flight controllers come already in bits, so you might not need to do this. Now to take these small screws out, I'm using a Phillips head 0 screwdriver bit, but I've been informed by Tracy Glenn that there's actually a JIS standard for crosshead screwdrivers, and a lot of these parts on flight controllers, servos and all that sort of stuff is actually using the JIS, which I believe is Japanese industrial standard. So I'm certainly going to invest in some of those screwdrivers, and it might be worth doing that too if you haven't already got a screwdriver set. Anyway, let's get this board apart. So we got some hard plastic, and actually it looks like it's soft mounted, which is pretty nice. Yeah, so this whole flight controller is soft mounted. Yeah, squishy. So now that this top board is off, which is actually the flight controller, we can see this bottom board, which is the power distribution board. Now on some of these setups you have the flight controller on the top, power distribution on the bottom, and sort of a mixture of the two. But some, like the F765 WSE and this one obviously, are separated out. And the reason for that is there's a much more powerful sort of servo BEC and other sort of step down voltages on these boards. So this one can control 12 servos, so it has the capacity to manage the power for that. But we can also get a better look here of the battery positive, ESC positives with our shunt resistor in the middle, and the negatives on this side. If you remember, the shunt resistor is basically what measures the current. We also have these pads here, CURR, which is our current, so that sends the current sensor value from the shunt resistor up to the main board. We have VBAT, which is the battery voltage. We have a ground, and we have VX, which is our servo voltage. And if you look on the side here, we can see two sets of pads. So we have a 6 volt here. If we bridge those two pads, we get 6 volts to our servos. If we bridge these two pads, we get 7.2 volts to our servos. Now on different flight controllers, this is in different places. If you remember in the last video, I actually showed you where it was on the F405 WSE, but it's all very well laid out on the Maytech website. So make sure to check the correct position for your flight controller. So with our servos, I will actually be bridging this 6 volt because I know the servos that I have are fine. And if you've picked any of the servos from my website, they will be fine too at 6 volts. The plug and play, I wouldn't risk it, so I'll just leave that as it is. So the first thing I'll do is solder some pins on. So as I mentioned, I'm going to use UART2, which is TX2, RX2, 4.5 volts and ground for the receiver, and TX6 for the GPS. So I'm going to get a couple of rows of pins on there. I'm also going to completely pin this section here for the FPV side. I'm going to put some pins on servos 3 and 4. Actually, I may as well pin all the servos, because if I put it in a different plane later, it will be easier just to plug stuff in. And I'm also going to put a pin on TX3 so that we can use smart audio on our VTX if we wish. I'll explain smart audio a little bit later on, but if your VTX can do it, or IRC Tramp, then it's well worth hooking up. The only other thing we need to do on this flight controller is under that rubber grommet is the bridge for the VTX power. So this is the switchable voltage for the VTX. So this pad right here, which it can either be bridging these two to make it 9 volts or these two to make it 5 volts. So I'll be putting that at 9 volt because the VTX I have is 7 volts to about 20 something volts. So I'll be bridging those two. What I will say is, if you're not confident with soldering, definitely practice first, because you can see there's lots of tiny components around here, and if you knock one of those off, it will damage the board. But also any like spits of solder balls on these chips here can cause you problems. Okay, so doing this is actually pretty straightforward. All we're going to do is cut off a section of our pins, put them in the holes that we want them in, and solder them from the other side. So the first lot of pins I'm going to add are the signals at the top here. So I will use the white for the signals. So we have 9 signals up here. And while I'm doing that, I'm actually going to put another set in the back here just to hold the thing straight. Might even be able to get them in both. Yeah, there we go. So I'm going to cut 9 headers off of this, and then we'll stick them in the hole, turn the whole lot over and start soldering. Right, so the key to this is just making sure that everything is nice and flat. And by putting these other servo or DuPont connectors here, that's actually going to be pretty flat, and we know it's also going to be straight down. So what I like to do is just solder up an end one, and that should hold it in place. And what we're going to do is get our soldering iron onto the pin and onto the board, so it heats both parts up, and then put the solder onto the joint, and there we go, take it away. So now we've got one in, I'm just going to make sure that it's square. So yeah, that's looking good. So now we can just continue down the row and get all these on. Luckily there's no small components or anything around here, so this should be a relatively easy job. But the key here, just get the iron on the corner so it heats up both the pin and the board, or the little through hole on the board. I'm just going to turn it around because I can't see this very well. Yeah, some of these joints could do with more solder. And those solder joints aren't the best in the world, but I'm actually struggling to reach over just so that you can get it on camera. So I'll just try and tidy some of these up. Well, there we go, that is the first row done. Just want to check, make sure that we have solder all around. And that's looking fine. So the middle row is the power. So let's cut 9 off of the red, and I'm going to do exactly the same. And again, just making sure that they're in nice and straight, and it will all be good. This is the most awkward part of the whole thing. There we go. So again, this is going to be exactly the same. So if you find that your solder is not flowing great, you can use a little bit of flux. You don't actually need a lot, but that will actually help it flow around the joint. A bit of pressure, and then let's get the end one done. So we have our signal and our power. Yep, you guessed it, the last is 9 on the ground. With the grounds, you may find that you definitely want to use a bit of flux. There's usually a bit more sort of, usually you need a bit more heat getting in there. And also clean your tip quite regularly, it does help. So again, a bit of pressure, and let's make sure that that one goes in good. I've actually missed the first one on the positive rail. But yeah, that's looking all right. Right, so I just grabbed a servo just to check the alignment before we finish off. So yeah, that's absolutely fine. So what I'm going to do is just get my little stand made up again, and we'll just finish off the solder, and I'll actually get that one that I missed. There we go. Okay, so they're all looking fine. The solder on all around the whole thing. So that is our servos done. So next up, I'm going to solder the pins for these UARTs here. I've decided I'm going to solder up the 3 UARTs because why not? So we'll have UART 7, 2 and 6 already soldered. So the first ones that I'm going to do are the TX pins. So we want 3 pins in white. So again, just make sure that they're nice and flat. We'll get our little stand at this end of the board. And what we're going to do is just make sure that it's quite straight up and down. You can actually, I can see it in from the side, so I'm going to make sure it's pretty vertical when I get the first one soldered up. And one little tip is when you solder, don't blow on it to make it sort of go off quicker. You'll actually oxidize the joint. Alright, so our TX is done. We're going to do exactly the same now with the RX. And at this point it should all stay quite level on its own. Alright, so next we have our power, so 3 reds. With this flight controller we're actually quite lucky because the top plate has actually got all the markings on there as well. So even though when we put the pins in we cover over the markings, we'll still be able to see them from the top plate. On some flight controllers we don't have that luck, unfortunately. But there's always the website, especially with Maytech stuff, as I keep saying, their website is actually very good. Right, and finally we need our black ones for the ground, so I'll just stick the white in here. Okay, so that's our UARTs done. I did mention that I'll also be doing TX3 for the video transmitter, but I'm going to do the video section first so that the TX3 actually has something to lean against, so that it's got a better chance of being straight. But before doing that, I'm tempted to just do this bridge here before actually getting pins on there. It might just be a little bit easier to get at, so just going to take this rubber grommet out to make life easier, and all I'm going to do is bridge between the 9V and this center pad here. Just be careful about these smaller components here. You don't want to get any solder on those, and also you don't want to get any solder balls on the main processor either. That would not be good. So there we go, just a nice clean solder bridge. Give that a little chance to cool down before putting the rubber grommet back in. But what we can do now is our camera section. So I'm going to be working this way towards that, so 3 more whites. Now usually I do actually direct solder the cameras, but I think it'd be easier to show the setup if it's with pins. But yeah, usually the only things I use pins for are the servos, if like the wings are removable. If you are direct soldering though, just make sure to leave slack in the cable so that there's no tension there. So let's get a bit of flux on there. Bit of pressure, make sure it's straight. Lovely. Right, red, power. Again, with soldering these ones here, watch out for these smaller components at the back. You don't want to be knocking, you don't want to be desoldering any of these little small components or getting solder balls on them or anything like that. That's asking for trouble. Okay, so the final ones, I'm actually going to put the 2 whites in for, actually I might as well put 4 in because we've got 2 UARTs there. So I might as well just put 4 in and be done with it. Alright, there we go. So what we have soldered up so far, we have all our servos soldered up. We have our 2 cameras and our VTX soldered up. We have 3 complete UARTs soldered up. 2 of them we're using for our receiver and our GPS. And also we've added these UARTs down here. One of them we'll be using for smart audio or IRC tramp if your video transmitter can handle it. We've also bridged our video transmitter voltage. Of course, you should check the voltage on your video transmitter to select which voltage you need, but the bulk of them run from around 7 volts to around 26 volts. To get a 5 volt video transmitter, you are really looking at sort of a specialist low power transmitter. So that's our main bit of soldering done at the moment. So let's get our little rubber grommet back in. Oh, this is going to be a SpongeBob 3 hours later section in there. Alright, there we go, we're in. We are in. Okay, so the next thing to do, if we've been using flux, a lot of it these days is actually sort of self-cleaning flux. This one doesn't say, so I'm going to give it a quick clean off. Now, what you use is some isopropyl alcohol and a toothbrush. So just dip the toothbrush in the alcohol and just give it a scrub off. So, there we go. That will evaporate pretty quickly. Probably not off of the cardboard, but certainly off of the electronics. It will evaporate pretty quick. So that's just wiped off and cleaned all the flux residue. Alright, so next up we're going to need to look at our power situation. Now let's turn this around so it's a bit easier to see. And that is obviously going to relate to this part of the flight controller. So we're going to need to wire up our battery, so probably to that pad and that pad. And then we have our ESC to that pad and that pad. And we can just bridge the 2 pads together just to give it more capacity. I don't think that this is going to stress the amp rating for this flight controller at all. It just gives it that little bit more bond rather than relying on the traces. Right, so these 4 pads here actually connect to current, VBAT to VBAT, ground to ground, and the servo voltage to servo voltage. So it's actually going to be using these pin headers here. I will check the manual to see what gauge it recommends. Next, what we can do is solder the servo bridge. I've mentioned quite a few times about the servos. If you're using PMP, don't worry about this. But if you're using the Emax servos are recommended, or the JX servos that I'm using, we can go to 6 volts absolutely fine. So I'm going to bridge that now. And this one you really do need to be careful. There's some really small components here that are very close to that pad. So make sure not to touch those. Because I want to be more careful, I'm actually going to get this in a better position for me. Clean off the soldering iron. There we go. Right, so our servos are now going to be running at 6 volts, which if you missed the earlier videos, well, go watch them. But the 6 volts on the servo will give us a bit more torque and a bit more speed. So it's well worth doing. So we've got basically everything soldered up on the board itself other than our bridging cables and our main power. So let's have a look at where we're going to put this in the plane and how long we need our battery lead to be. Right, so here's the back of our Dolphin. You can see I've unscrewed these standoffs, which has left these tiny little sort of nibs in there, or the bolt parts. And you know, without taking this bottom plywood plate out, the only thing I can really do is chop them off with a chisel or something like that. So that will be happening. But before we do that, we can just take a look at where we're going to put our flight controller. So the great thing about these wing style flight controllers for fixed wing aircraft is that the power and the ESC connections are always pointing towards the back of the aircraft. So basically it means the alignment of our flight controller is the correct way around. So the arrow on the top at this stage is pointing forwards. So it gives us a little bit less to worry about. We know that if we're wiring it up in this sort of configuration, it's going to be right. But if you have chosen a different flight controller, at this stage, you really do need to think about the orientation. So the arrow on the flight controller, obviously for the simplest setup, you want facing forwards. So just bear that in mind at this stage. Now I'm going to put it pretty far back, I think, probably about here, so that the power section is just hanging off. So I've decided that I'm going to run the battery cable around this side. The reason for that is the VTX position is on this side, so that makes more sense for the video cables to go this side. So what I'll be doing is running the power on this side, the video on this side, so that they don't interfere. So we have plenty of cable for our ESC, and then we have our signal and our telemetry here. It's a little bit of a shame that there's no like signal for the motors and one UART on this bottom board. That would make it so much easier to install. But we've got what we've got. What we need to do is measure up some battery cable. Oh, so back when you could actually buy stuff from Hobby King in the UK, I got this cable here, which is actually really quite handy and neat for builds. So the actual cables are molded together. Now this is AWG 14, so it will be absolutely plenty for this. And if we do decide to put a crazy motor on it, then it will also be fine. So what I'm going to do is put this on near the positive terminal where that's going to go, because that will be the furthest one away. And I'm going to loop it round, and I'm going to go to around about this point here. Now that might seem quite short, but the reason I'm going to do that is because it will give me the option to run 2 batteries. If you're only going to run one, you could run this cable all the way into the front section, but all I'm showing here is that you need to measure out the cable. But this will give me the option to either have an extension lead just into the front, or to have a split cable so I can power both batteries in parallel. I'm going to just cut it here, and we'll then solder this onto the flight controller. So we've got our cable cut, but before we put it on the flight controller, we might as well get our XT60 on here first. And the reason for that is because it would be easier to do it on the desk without it being attached to anything. So if you're using twin cables, you won't need to split the ends, but I do. I need to leave enough to get some heat shrink on there. All right, so let's get in our box. You're bound to get stuff like this later on in the hobby if you haven't amassed it already. So this is the XT60 that we're going to be having on our pigtail, and this one I'm going to just use to keep everything in line when it heats up. First we just trim off a little bit of the shielding. You can see it does actually go quite deep inside there. Next up we need to pre-tin the leads, so I'm going to put a bit of flux on there. Right, so we'll heat up the cable. And let the solder flow into the cable. Usually I sort of get a hold of it with my hand or something to stop it moving, just so you can keep the pressure on it. But this trying to do it on camera is awkward. I keep saying that, sorry. But there we go. Let's try that. Once it starts flowing, it's fine. There we go. So we've got a nice bit of solder on there. Let's do the same with our positive. We basically are trying to avoid getting little strands poking out. There we go. Right, so there's our XT60. On the actual plug itself, you will see a plus and a minus, so we know which is positive and negative. So again, what I'm going to do is pre-tin these, so I'm going to just basically fill this up with solder. And then what we're doing is, so the flat side is positive, we'll do that first. So we get our heat shrink on, get it up, and try and hold it up the end. And let's just get this heated up. Get that heating up, and then they'll sort of just push in. Now at this point there are gaps, but that's fine. We can come back with our soldering iron and just get it nice and full. So there we go. Let's get our heat shrink over, and that will actually start shrinking down already. And then what we'll do is repeat the same with the other side. Of course, this is still bloody hot at the minute, so be careful. But all we're doing is heating up this, and then we'll be poking our wire in the hole all the way down. And if we need to put some extra solder on, we can. And then slide the heat shrink up. As you can see, the heat from the solder is actually just heating it around there. So when we go to actually heat this up properly, it's already held in tight. Alright, so the reason for putting this one in is to hold the pins level, because this does actually get very hot. And if you melt the plastic a little bit, this will actually help keep everything in line so that you don't end up with a dodgy plug. But that's gone on pretty well. Next up, you just need a heat gun to heat the heat shrink down. Alright, so that end is done. We can leave that in there till it cools down. But now what we want to do is this end to get it hooked up to our flight controller. So because I'm coming out that way, what I'm actually going to do is make the negative slightly shorter. So the positive will go on here, and then I'll bring the cable round and make the negative cable a little bit shorter just to get it going around the right direction. So let's just do the positive first. And this time I'm not going to take off so much, just enough to cover the pad. So that's perfect. And again, we're pre-tinning this, and what we'll do is also pre-tin this pad here. And while we're here, we may as well pre-tin these, so I'm going to need one for an ESC, and we're going to need battery negative and an ESC negative. Now it doesn't actually matter which way round this is, because they're all on the same rail, and actually I'm going to bridge them together anyway. And while we're here, let's get some, we might as well pre-tin these because they need to be hooked up at some stage anyway. So they're ready to go. Alright, so let's get our battery positive on. And it's actually, I find it a good idea just to stand stuff on things to stop them moving. So this actually looks like it's going to be quite good anyway. But that's going to be going on there. And we're just going to heat it all up and just apply the solder. And again, a bit awkward for me, but Of course the heat has to go through the wire onto the pad, and let's just get a load on the pad. And on the shunt, let's bridge it nice. So there we go. So by doing this, we're not just relying on the copper traces on the PDB, we've actually made a nice solid joint between this wire and the shunt. So that's going to be handling a nice amount of power. And you can see sort of like this sort of glossy flux, so we'll obviously clean this off again afterwards. We've got our power cable coming around, and the negative I'm going to put in here, so I can actually cut that off at that point. And this is a bit of a smaller pad, so I'm going to take less of the outer shielding off. And now we're back to the same old routine, bit of flux. Let's get that up in the air a bit, and let's get that pre-tinned. And now this is the tricky part where you could end up with burnt fingers. Because this can now move about, what I'm going to actually do is tape it to the desk, and hopefully that will give us a bit more support. So now what we can do is get some pliers, get our cable and hold it in and melt it down. Get a bit more solder on there because we do just want a nice big joint. And that is looking pretty good. So when that dries, yeah, it's nice and shiny. I'm not happy with this one. That's better. Okay, so that's our main power in. We can bridge these to when the ESC goes on, and obviously the ESC will get bridged onto this side of the shunt too. So that is our main power. All right, so after all that praise about the Maytech manuals on the website, there's actually no specification for the size of wires we need for these 4 pins at all. So what I've found is some 18-watt American wire gauge. Now, I would not recommend using all the same color. I'm just doing this because this is all that I have. But I want to put something fairly substantial on the VX, the VBAT and the ground. The current is just a sensor, so I'm just going to use some standard sort of 22. That should be plenty for this. Probably even smaller, 24, 26 will be fine for the current. But for the V background and VX, I want to make sure that I'm using something that can handle a fair amount. You can see it's too big to go in the holes, but I will just solder it directly to the pads. So yeah, that is the plan. And what I'm going to do is just connect them on this end. And I'm not actually going to connect them to this board until everything with this bottom section is in. Fortunately, they're in the same order, so we've got VX, ground and VBAT, so getting them wrong shouldn't be an issue. But what I will do is just cut them down slightly, because they don't need to be that long. Yeah, they only need to be about half that length, so I'll cut them, well, 2/3, and then I'll just use let's use the blue one just to be different. Ideally, it would be better if we could solder the ESC first, but because we're going to do that in the plane, this will be easier to do now, even though it will sort of be in our way. And all I'm going to do is give these a little bit of a tin. And let's get them on our pads. So okay, so those 3 are on. I've just got them folded up just to make it easier to get to the ESC. And just need a bit of blue, the same length. Okay, so that is the lower board complete for the time being. So the question is, do we get it in the plane now and finish that bit off? Yeah, why not? Okay, so this has actually worked out very well. So I can loop that around and put that in here. So what I'm actually going to do is turn it back round and just put a marker on the side just so that I know when it's approximately straight. It doesn't have to be exact, but that little mark in the wood will then let me know when the flight controller is straight. So what I think I'm going to do is, that's obviously going to get stuck in there. There's plenty of slack there, so we've got plenty of cable. We don't have to be having pressure on this at all. But what I'm going to do is leave these ESC mains cables reasonably long, because then I can lift the board up to get the solder on, and it just keeps the heat away from the foam. It might have actually been a better idea to do this before gluing these in. Maybe if you're following along and you haven't started building yet, leave this till last, because it'll be a bit easier for doing stuff in here. Let me get a little box. That might be too tall. Actually, that should work. That should work. Let's put it that way so it can't move. And I'm going to tape the flight controller to the box. All these little things just make life a little bit easier. So our flight controller shouldn't move. Let's get these cables out of the way. Again, we could tape those. And now all we're going to do is solder on our two big leads. So I'm going to get the other two ESC cables out of the way, because they obviously go onto the flight controller itself, not this power distribution board. So let's just drop a little bit of flux on there and on there. Just trying to work out where we can both see it. Okay, so there we go. It helps to be a little bit ambidextrous. So yeah, if you struggle with this, don't worry, it's just natural. These sometimes things are just a pain, and there's not a lot you can do about it. What I'm tempted to do is actually bridge these now. And then I can get this into this side. So there we go, there's our main power. We have our battery positive, our ESC positive, and they're both soldered to the shunt resistor. We have our ESC negative and our battery negative, they're both soldered to the pads and bridged to each other, so that is a nice solid joint there. So that is the bottom plate soldered up. So the last thing is to brush its teeth. So this will just get rid of the excess flux that's on there. This won't hurt anything other than hot glue, so if you're using hot glue, be careful with the IPA because it will melt it. So we could also get a bit in there. Right, so that is our bottom plate done. So what we can actually do now is stick it into the plane, because the rest of it is all going to be on the flight controller. So what I'm going to do is get out some sticky pads and get that stuck in right there. So what I'm actually using is this double-sided thick squishy tape. This is Gorilla, but 3M is also decent. But you can see it's quite thick tape and it's quite a strong ultra high bond. So what I'm going to do is turn the flight controller over, and I might just do a piece down straight down the middle. Alright, so I don't need to go right the way to the end because the end will be overhanging slightly where I'm sticking this in. Peel off the backing tape. You can see it's a good sort of millimetre or so. So the vibration dampening on here will help, but this will also give a little bit of help too. So let's get those cables through and get it into position and try and just get it reasonably straight. So I'm going to come backwards a bit just for CG more than anything, but it gets these power pads off of the ply, and let's give that a push down, and that's solid. Yeah, so that's not going anywhere. Alright, and because these are the only things we're actually soldering to the flight controller, everything else is push fit, so to speak. We could actually get the flight controller in position now. If we were direct soldering, then obviously we'd probably have a bit more work to do. So what I'll do is get these trimmed off and tinned. Now at this point you still want to be very careful because obviously we're doing soldering and the beck is right below it. So you want to make sure that you don't get solder balls or anything like that near it. Alright, so those wires are now soldered up. Apologies if you don't have a flight controller with this on it. Obviously you can skip this section. In the chapters will be points to specific parts of the build. Right, so let's get the ESC connected next. So this white wire here I'm going to put into S1, which is our signal. So let's put it through the board, and it'd be nice if something would hold it up. Get a bit of flux on it. That'll get the solder flowing in there nicely. And again, we want to try and heat the wire and the pad, and be careful. And that's on there, it's a nice connection. So that is our S1 pad, which is our motor 1 out. And the other long blue cable that comes from the ESC, I'm going to put on the RX8 pad on this flight controller. This is for the ESC telemetry. If you're using the plug and play, you don't have that, unfortunately. But if your ESC does have the telemetry cable, put it on a UART receive pad, that's the RX pad, near the back of the flight controller, just so it's easier for you to access. And again, just try and avoid the other components. You don't want to knock them off. There we go, that's on there. So that's our ESC wired up. So those four are all going to go in between those two. So now we're just sliding the flight controller back onto those rubber standoffs and just giving it a push. I think I'll leave it higher up just because it'll be a bit easier to solder these other pads on. So we have the blue one for our current sensor. I'm going to do these all just on the top. That could have really been done as a through, but I think just sticking it on the top will be fine. Actually, I will do it as a through, but I'll do it as a push through. There we go. So that is the current sensor connected. Apologies for it going out of focus all the time. And these three cables here are now going in order. I'm just going to tin up we have our VBATs. We have our ground. And finally we have our servo voltage. Okay, so they're on there, but before powering anything up, what we're going to do is just make sure that they are going to the right places. So next up, we want to make sure that they are connected to the right places and only those places. So what we're going to do is use a multimeter to check for continuity. Now there's the ohm setting where if it says OL or off limits, then it's not actually connected, but if it gives you a value, then there is some connection there. There's another easier setting on some multimeters, which is just a continuity test. So if it says OL, there's no connection, but if it beeps, then there is. So for example, if I go to this ground pad here, we'll get a beep because they're connected through the flight controller. But if we go to our VX pad, we shouldn't get any beep at all. That shouldn't be going to ground. Same with the VBAT and also the current. And we can also, these are all ground down here, but that one there shouldn't be, neither should that one. Sorry, that's skipped. But this one in the middle should be ground, but it should also link to the ground on here. So we could actually just go to the ESC negative pad down here. And if that connects to ground, that's fine. And again, these two shouldn't, but the middle one should. Right, so the next one to check is the servo rail. So obviously the power in the middle here on these middle pins is going to be linked to this pad here. That's expected, but we want to make sure that that is going to the correct place on the PDB. So there is a VX pad just down here. We can connect that to the not the middle, that's ground. We can connect that to this outside one, and that worked, and also these pads here. So that is absolutely fine. The final one to check is this VBAT. So again, we can just use our big battery pad, and that should go to there, and it shouldn't go to any of the others. So those wires here are fine. As long as our current sensor wire isn't connecting to the VBAT or anything like that, then it's all good. But if you want to get that pad, you can go to here and just touch it on here, and that's fine. So we know that that connection is absolutely fine. And also what we can do is put it on the main battery positive and the ESC pad, and if we don't get a beep, it's all good. That is a basic initial check, but we will obviously use a smoke stopper on our first plug-in. So where are we? Our bottom board is now finished. Our main battery power is connected. Our ESC is also connected. We've connected our bridge between the top and bottom boards, so we can actually just push this down now and fix everything back together, because at this stage there is nothing else we need to do here. We're just using our pins. So what we'll do, we'll put our little spacers in and we'll put our cover back on. While I'm here, one thing I did notice on the Maytag website, if you're using this flight controller and your VTX needs 12 volt, you can bridge these two pads here to get 12 volt. Now, most of the time, the 9 volt will be absolutely fine. 12 volt is only really if you're using some 1.3 gigahertz video transmitters, which sort of demand 12 volt. But for most cases, we don't need to worry about that, which is a good job, because there's a lot of stuff around here where if you get that soldering wrong, it will mess everything up. So let's get our plate back on. Right, so our flight controller is in, so we need to start planning now where we're going to put the rest of our stuff. Now, at this point, if you have your battery, it will probably be worth grabbing it so you can test out with CG. Where I'm eventually going to go to a heavier setup anyway, I don't need to worry too much about it because I can move stuff around. Ultimately, what you want to do is get it so that the battery you're going to use is in the front, and when you position all the components, you can get it to balance on CG. Now, if you remember from the earlier videos, there's a CG mark on the wing here. Have the wings in, obviously balance the CG mark when everything is in, prop is on, everything is in place, the plane is balanced. Okay, so excuse the mess, but let's just demonstrate the CG. So you'd obviously have a prop on, both hatches on, and the marks underneath you feel with your fingers. So at the moment it's very tail heavy, but then there's no battery in the front. So this is a 3S4000, which is not the battery that I'd be using. But I'm just going to rest it in the front just to show what happens. So still a bit tail heavy, so let's move the battery forward. You can see now it's quite nose heavy. So the idea is the battery that you want to use when all the equipment is in there. That's a bit tail. There we go. So when all the equipment is in there, you should be able to balance the plane on your 2 fingers. And obviously this is not the right battery and all the equipment is not in there, but you can see that it's actually just balancing there. I'm not actually supporting it. I can't quite see it on my webcam. If anything, it could do with a little bit more weight towards the nose, but it's just a demonstration. And that is on those 2 CG dots there. So when you're testing out where your stuff's going to go, you can actually just rest stuff about the place. So for example, I know the FPV camera is going to go here, so I can just rest that here. I can stick the VTX around there, put the receiver about there. GPS, I've not decided where that's going yet. I'll need to by the end of this video, but it potentially could go, that's probably a bit too far out for, let's stick it up there. So that is actually balancing pretty good. So that's not a bad position for those components. Of course there's no prop on it, there's stuff missing, but this is roughly how you lay stuff out. And if you've got enough room front and back of that battery, you know you can slide it backwards and forwards. So for example, if we were to put a GoPro in, we could probably slide that all the way back and still hit CG. So that's what we're aiming for, is just to get all the components in, get everything balanced. So next, that's what we're going to do. Right, so I'm actually going to leave it there. This video is already over. It was almost 2 hours 20 minutes on the recording. Obviously that will edit down, but basically it's long enough as it is already. So in the next video we'll carry on where we've left off. So we'll get the camera installed, we'll get the VTX installed, we'll get the receiver installed. What I've got on the desk there is a FreeSky R9 MX receiver, so that covers FreeSky. I'll also show how to wire up a Crossfire protocol receiver, so that covers Crossfire of course, but also Express LRS. We'll get the GPS in, and then after that we can start configuring iNav. So I hope you guys have found this video useful. Thank you very much for watching, guys. I'll see you on the next one.